that create a huge damage to Russia. So that the way the warehouse robots are there, automated logistics are there. So this automation play a crucial role. And a unified system also. You need to be combine your sensing plus communication plus localization. These three are going to be play a major role for any particular communication in the future. For example, you take you may order order through Swiggy or Zomato. You require to provide location or not. Yes, it's location dependent. Even your internet accessing is slightly moving towards it is connected to a localization. Last couple of months back, I went to Korea. I plan to access a particular application. They said, okay, you are not in the specified location. Because of that, you are unable to access this particular application. Means internet accessing is also going to be based on the localization. So you observe, Industry 4.0 supposed to be used sensing, communication, and localization as a unified system, as a unified system. And you need to be observe the 6G threat landscape. It is wide variety of it's very different whenever you are going to be observed this particular 6G threat vector, and that is going to be different. We'll see how is it. You observe 6G communication. First we need to come to 6G communication. This is the inner circle, that means a pentagon is there, and this surrounded by a circle. Inside this circle you observe, very carefully observe what are the applications are there. RAN core convergence. What is meaning of RAN? Radio access network. And intelligent radios are there. What is there? Intelligent radios. The brain is going to be provided to these base stations. How brain is going to provide to base stations? With help of artificial intelligence. And there are specialized subnets are supposed to be emerged, because everybody looking for their own private communication. That means you need to provide a kind of concepts called a network slicing. What is the network slicing in here? That means end to end is going to be created a tunnel. The packets are moved through the tunnel only. If people are feeling like that, bandwidth also it's going to be allotted for that communication. Nobody is not going to intervene in that particular communication. That means whatever the physical resources are there, they're dividing the physical resources into a digital way. So that virtual resources are going to be assigned to the people. That's why network slicing, network function virtualization are emerging nowadays. And another is going to be cloudification, edge intelligence. This is another great mechanism. Especially mobile edge computing. Will play a crucial role for the future applications point. And intelligence network management, orchestration, and device consumer, and etc. are also part of this inner circle. Based on this inner circle, you observe they divided into how many? 5 different things. One is the orchestration, end-to-end user devices, functions, specializations, and platforms. I would like to bring a great discussion over here. Before I want to move to discuss about this particular data privacy threats, AI, ML attacks, security threats on cloud, security threats on edge, I would like to introduce a few artificial intelligence concepts are very, very well suitable for communication point of view. That's why if you supposed to be understand about a particular 6G security threat landscape, you're supposed to be understand what kind of communication methods they used. If you're supposed to be use these communications with AI, so you are integrating two technologies, one side 6G and one side AI, then this will create a new threat opportunities. So what kind of new threats are there? how to defend that new threat applications also we need to understand. Are you clear? So now I will come back to this slide. Before I am going to be close this side, first I need to be introduce few new concepts for you to understand. For few new concepts to understand, right? Here, yeah, here these are the security aspects. But I want to bring you to discuss about this AI security or ML security. Right. Here you observe machine learning methods for security. And here there are major concepts are there: applications of machine learning and crowdsourcing to adapt cybersecurity tools to the needs of individual users. And personalized security settings are required. And crowdsourced threat detections are important for us. However, there are supervised and unsupervised learnings are there, but the major role here going to be play a feature engineering, and the feature engineering is going to be depends on your big data. But big data right now is going to be completed. Nobody is not using the big data word. People are using, instead of the big data word, massive data word. They are supposed to be used. That's why massive data applications are emerging. So the massive data point of view, machine learning is also going to be used. Different kind of models here. And you observe security for a feature learning is going to be inside threat is there, malware analysis is there, network analytics is there, secure coding is there, situational awareness, etc. are there. That the way the combination means one side you are a networking combination, network security point of view, blockchain, AI is also going to be part of this one. Finally, the 6G or IoT devices are going to be used for sensing and communication point of view. AI is going to be used for thinking point of view. Blockchain is also used for remembering point of view. So here, whenever you are combining these technologies, two major concepts are going to be emerging. That two concepts are going to be, one is called federated learning. What is called FL? One is called federated learning, and other one is called split learning. Split learning. This federated learning and split learning are different with our traditional artificial intelligence mechanisms. So here, federated learning and split learning both are decentralized learning, or both are can be used for the what we can say. Both are going to be used for the collaborative learning point of view also. Collaborative learning point of view also. I would like to give a small example for you to make you understand about the federated learning. You observe there is a global node, and so many client nodes are going to be associated with this particular global node. So model is going to be prepared at the global node. That model is going to be shared to this client nodes, and the data is available at the client node, and the data is going to be provided to train the received model from the global node. So such a way that each and every node is going to be trained and send the weights to global node. Weights or gradients, whatever we say, whatever the parameters are there, will send to the global node. And global node receives parameters or gradients from each and every client, right? It aggregate all the weights with help of some algorithm that we call as a Fed averaging algorithm. So why we need to study about this federated learning? This learning is a distributed and decentralized, and your network is also distributed and decentralized. That the way it helps us to develop new applications, as well as you observe here one beautiful property is there in the federated learning. The beautiful property is going to be the data is at your side only. The data is at your side only. Because of that, you don't worry about your data. So I would like to show you, okay, another set of slides to understand you, make you understand about this, okay, federated learning and split learning, and I will come back to discuss our security aspects actually. Yeah, here, yeah, you can observe here the federated learning, how we need to be understand the federated learning. Yeah, here you need to be understand. And machine learning on sensitive data and privacy versus utility. The privacy and versus utility you observe, existing traditional artificial intelligence mechanisms are okay, chosen Pareto friend as a minimum. But the main new technology is going to push this into maximize. Our goal is going to be privacy should be high and utility is also going to be high. But the previous traditional okay machine learning algorithms are supposed to be used. The privacy is going to be given low priority, and utility is also going to be because of that. Okay, utility is also going to be a low priority. So that's why we need to be push this Pareto frontier with a better technology. That is called federated learning. So whatever existing mechanisms or existing traditional okay learning mechanisms are there, that may not provide this kind of okay features to our artificial intelligence mechanisms. This was introduced by the Google only. This was introduced by the Google only. How this federated learning emerged, you're supposed to be understand here. Okay, there are huge number of devices are there that we discussed just now. 6G, 5G communication, they meant to connect the devices, massive devices. If these devices are connected, these devices are going to be generate the data. So the billions of phones and IoT devices constantly generate the data. And this data is going to be enables to develop okay, smart and intelligent products. For that, you need okay, very that means okay, intelligent okay models to develop it, because data is going to be born at edge. Edge means that right now just I need to tell you one of the major concept in our 5G, 6G is going to be edge computing. So here that we will achieve with help of this one. And data should process data should process at a device, or data should be moved to any cloud or any third party services. So as far as the point of view, you should not leak your data, because the future, the fuel is going to be data only. The future fuel is going to be data only. That's why always you need to be keep your data at your side, and you need to be work on offline, and you need to be save your battery life, and okay, your privacy advantage is also there with that. But how we need to be achieve analytics and okay learning, that is very tough, right? Because of that, okay, there are three choices are there. Don't use data to improve product and services, log on the data centrally anyway, and invent a new solution for that. Which one we would like to choose, that's in our hand. But always we supposed to be choose invent a new solution. That invented new solution is going to be federated learning and analytics. Federated learning and analytics. Right. What is federated learning? You're supposed to be observe here. Here, the brain is there at somewhere. The brain we call it as a global brain. The brain you should be feed to the local device. The local device is going to be generate the data. The data you should feed to this okay, brain, and this brain is going to provide the information to your okay, that means okay, your okay devices, and that will be generated new data, and it will be trained. This is going to be a continuous process, and this process, whenever it is converged, immediately send the gradients to the global node. Global node is going to be provide aggregated gradients to the device again. This is the major concept actually. That's why federated learning is emerged. So federated learning is emerged. You observe here, initial untrained model is there. That untrained model developed by the global node, and each and every device has local database that we call as a local training data, and each circle is going to be present here as a mobile device. So here you observe the server select a sample of 1,000 online devices. You have a massive devices, huge number of devices there. Don't select all the devices, select few of the devices. Select few of the devices. And initial untrained model is there. That untrained model you can share with all the selected devices. With all the selected devices. Are you clear now what I'm saying? Untrained model is there at the global node. That untrained model is going to be shared with all the selected mobile devices. All the selected mobile devices. So this particular the received untrained model should feed with help of whatever data is available in your device. That we call it as a user compute and update using local training. So that you need to be observed. The data is going to be used, and the data is going to be feed to this model through the particular TensorFlow or XYZ concepts. Now, once you train this model, the model is going to be generated weights. That weight should be provided to the global node. So each and every individual node should provide that that particular trained information, trained model. That means a trained model gradients only need to be forward to the server. Now server receives this one. Server is going to be aggregates users features and updates into a new model. Again, that new model is supposed to be sent back to the devices. Here you observe, data we are not sharing. What we are sharing? We are sharing only the parameters, model parameters only. We are sharing. We are not sharing our actual real input data. Actual real input data. So composable with a strong privacy guarantee, which well described in a bit. So once this complete the training is happened, then deploy the best model to all the devices, so that the should be reached to all the devices. All the devices. Are you understand how different new learning method it is, the federated learning, right? Yeah, I'm coming to. I don't want to go for giving in this average algorithm with the stochastic gradient steps. My main motive is going to be introduce to you this federated learning. How federated learning is supposed to be used for communication is my another discussion. So now you might understand how this federated learning is. How this federated learning is. There are different type of federated learning concepts are there. That we need to be understand. How we need to be understand, I would like to explain you. Yeah, I would like to explain in our slides only. Yeah, here you supposed to be understand. Not here, I need a white slide, such a way that I can explain you. Yeah, here I can explain you about. You observe here, you forget about this blockchain, and here I need to explain that federated learning concept again. So we discussed about the federated learning. What we understand about federated learning, there is a global node. Global node, I am writing GN. There are local nodes. I am defining L1, local node 1. local node 2, like that local node k, local node j is there. Am I correct? These were selected. These were selected for the training purpose. Now, okay, you received a model, and you train the model, and you are generate the model parameters. That model parameters you share with the global. Am I correct? Here we have, okay, three different type of FL mechanisms. One is HFL, and second one is VFL. Third one is FTL, and fourth one is FRL. FRL. What is the HFL means? Horizontal federated learning, vertical federated learning, federated transfer learning, and federated reinforcement learning. These are you clear now? What is HFL? HFL means you're supposed to be understand here. Suppose I want to discuss about HFL. First, you need to be observed. These are your samples, and these are your features. This is your, okay, suppose, okay, you need to be observed. This is your sample space, and this is your feature space. So sample space is this one, and feature space is this one. Now you can observe over here, wherever the overlap portion is there, this overlap portion is supposed to be understand here. What is called here? What are common here? Features are same. Features are not, okay, changing. What are changing? Samples are changing. What are changing? Samples are changing. But features are in the constant way. The features are not changing. This is, we call it as a horizontal federated. At the same time, you observe, okay, another thing, okay, over here, what is it? This green line. Here, what are the same? Samples are same. Samples are not changing. What are changing here? Your features are changing over here. That's why we call this as a VFL, vertical federated learning. So I don't want to give, okay, a huge number of applications are there here. Instead of that, we need to be observed what are the applications are there at a vertical federated learning point. Vertical federated learning point. In this vertical federated learning point of view, I would like to give a small example to you, make you understand. This is the global node. This is the global node, and okay, you have, suppose, okay, three clients are there. And these three clients, suppose your model need to be trained. You need, okay, 10 features are there. These 10 features are going to be distributed among these three nodes. 3, 4, 3. Means 3 features are available here, 4 features are available here, and 3 features are available here. But if you want to train your model, what is supposed to be required? 10 features are supposed to be required to train your model. Means these 3 are supposed to be send their model parameters, then only this model can train over here. Individually, these clients cannot able to train over here. That is the beauty of the virtual, the vertical federated learning. And there is a federated transfer learning, federated reinforcement learning is there, but mainly we need to be understand about, okay, these are the topics are there. Another interesting concept, okay, which I mentioned you to discuss, what is that? Sorry, I need some space here. Here space is there, right? That is called, okay, split learning. What is split learning? In the split learning, you observe here, okay, the major application is there, okay, based on the split learning. Suppose our, okay, edge devices are resource constrained devices. Our edge devices are resource constrained devices. We can't able to store we can't maintain a database. We can't process our, okay, we can't feed that, okay, data to our model. But because, okay, the model training and model convergence will take a longer time, then the energy consumption is going to be high, such a way that your devices are not supposed to be stay alive more time. Because of that, they introduced this split learning concept. What this split learning is stating, you split the model. Suppose your model consisting 7 layers, you keep light layers with the client and dense layers are going to be with the global model. So four dense layers are there. Suppose four dense layers are with the global model, and the client at the client side, okay, three models are there. 3 layers are there. When it's total 7 layers, 3 layers are here and 4 layers are here. That means once you train these 3 layers, so your data is there, data feed to these 3 layers, and these 3 layers are going to feed to these 4 layers. After this 4 layer, okay, whatever the output is coming, okay, that is going to be iteratively solve the problem, and okay, it will provide. It's just one of the very interesting and emerging, okay, topic right now in the decentralized learning side. Decentralized learning side. Right. I think, okay, I might introduce, okay, these two topics. Why? Because we don't have a time. I need to be cover security. I need to be cover artificial intelligence, and I need to cover, okay, 5G communication because of that. So now I will move to my personal slides. I would like to come over here, the security and privacy point of view. Now we would like to discuss about, okay, the problems over here. Here you see data privacy threats. The data privacy threats we are supposed to be solved with help of your, okay, split learning or federated learning kind of concepts. However, it is going to be create a new type of, okay, security problems. New type of security problems that also we supposed to be solved. That also we supposed to be solved. Why? Because you are introducing a new type of, okay, ML concepts. Whatever existing ML concepts are not supposed to be achieve privacy. So that's why you are using a new kind of concepts. But this new kind of concepts also going to be compromised to a different type of attacks. That we call it as a data poisoning attacks and model poisoning attacks, or model inference attacks, or member inference attacks. Whatever the names you can able to say, that means, okay, we try to understand how data poisoning attacks are there. Simple. You observe federated learning architecture, that in the federated learning architecture, clients are feeding the data to model, and model is going to be generating the parameters. That parameters you are sharing to global. That parameters you are sharing to global node. These parameters might be poisoned with help of data. How? Yes. Example, I would like to tell you, your global node is going to be just perform aggregation. Example, I may provide a 1 plus 2 plus 3 plus 4 like that. 1 plus 2 plus 3, 4 divided by 4, how much? Around, okay, it would be 2.5, something like that, it will be there. Am I correct? If suppose the first person 1 is there, instead of 1, it might be provided minus 4, what happens? What is your average? Means malicious intent users are there. These users are supposed to be manipulate your model with help of data poisoning attacks. With help of data poisoning attacks. There are several different type of data poisoning attacks. That's why differential privacy is emerged to solve that problem. And another is going to be, okay, model poisoning attack. It's a to back propagation. In machine learning models, what is the back propagation is there? Through back propagation, they're supposed to be learn the data. Means, okay, they are going to be receive the gradients and model point of view, and with help of the gradients, they're supposed to be regenerate the data. That the way AI point of view, more attacks are available. And you observe in 6Z point of view, in the orchestration point of view, and platform point of view, specialization point of view, and functions point of view, one common problem is there, that is AI by ML attack. AI by ML attack, AI by ML attack, AI by ML attack. So this AI brings new threat vectors. We supposed to be understand what kind of new threat vectors are going to be generated by AI whenever it is going to be combined with 5G or 6G communication. Yeah, I supposed to give a small example. Suppose you are using an autonomous car. That autonomous car is going to be generating the location. Suppose I want to mistrain your autonomous car. What I supposed to be do? I will feed wrong location to your car. If I may feed a wrong location to you, that means the data whichever I'm feeding the location data, that is the wrong location data I'm feeding to your car. Then where your car will go? Your car might be go to deep forest or deep sea, deep river like that. So that's why we should be more keen about this privacy and security aspects, right? And one more you need to be observed here: security threats on cloud, security threats on edge. We discussed about this one. Trust violations are there, and physical layer security is also going to be emerging, especially beamforming point of view, pencil beamforming, and you need to be observed cell-free communication. Cell-free communication is also going to be achieved with help of AML. If suppose you are using AML concept for your cell-free communication, then also you require to address this new threat vectors. New threat vectors. That's why 6G security is so wide, and it creates it's going to be that means open a door for many new attacks. That based, I would like to tell you, in 3GPP itself, they are providing so many recommendations. So AML is supposed to be used for the 6G communication. Your RAN maintenance is going to be with AML. Your beam maintenance is going to be through AML. Your connections are going to be through AML. So because of this, you need to be observed 6G communication is going to be much more complex whenever you are combining with this kind of new AML techniques. Right. So that's why try to understand security for 6G architecture, security of 6G AI technologies, okay, how they are significant to develop a new that means security solutions. And another is going to be, you need to be observed here, zero energy devices. Zero energy devices. And here, one more concept is there, zero energy devices point of view. Why? Because battery-less, backscatter communication enables the battery-less devices, and massive data or big data supports massive continuous data collection for the analytics, and responsiveness, create a highly responsive automated environment with the closed loop control also. And that means you need to be step into these devices. You try to understand the 6G security problems and security threat vector supposed to be understand. Clear? 6G has huge number of applications. Those applications we try to understand. After that, we try to develop security aspects. And here you observe here, the DOS attacks are emerge. These DOS attacks are going to be create a lot of problem to the future applications. You observe three, 3 terabytes of data they used to create a distributed denial of service attack on somewhere. And user privacy threats are there. And physical layer level. Suppose I want to disrupt your communication. Why? Because ultimate your activities depends on the communication. I should disrupt your communication through some kind of signal jamming, etc., 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 etc. Right? Yeah. I would like to give a few case studies which we were recently completed security problems related to the AIML for the 6G point of view. Yeah, here we need to be, this is not, okay, just a minute. The two case studies are there. I would like to discuss the two case studies for you. Yeah, my slides are visible to all of you now. Yes, these slides are visible to you.
Yes, sir, it's visible.
Yeah, thank you. So this is one kind of that motivation of the problem. Okay, the problem with the existing the communication and computers. Future quantum computers will come. Quantum computers are supposed to be create a problem to your existing security algorithms. That the main target here we are solving. The quantum resilience and real world applications are going to be are there. Mainly we need to be develop post quantum cryptography security solutions. Now you observe here. In this, user one is there. User one can create a avatar in 6G with the help of the 6G environment. That he might be create avatar one, avatar two, like that avatar K, and he might be attend virtual classroom, virtual meetings, and virtual gaming kind of activities. The same thing, other user also there. They are also going to participate in the same kind of activities also. That the way the metaverse server is going to be helpful for you. How certificates are going to be generated and are exchange between them are there here. This is the one system model is going to be a case study for our communication, right? So these are the algorithms are there. And another very interesting part here I want to discuss with you that are going to be, just a minute. I want to show you another one. Yes, that is another one. Just a minute, I'm sharing my slide. Yeah, this is one of the use case study for our discussion. I'm sharing my slide. Can you able to see my slides now? Yes. Yeah. Yeah, this is okay. One of our okay, major okay, research problem we are solving for the 6G point of view. You observe here, what is the problem here? Advanced AI models are powerful for detecting new threats, but their internal logic is opaque. Means you need to be observed here. The multimodal concept is there. A single model input is going to be received by this black box model, and because of this various inputs, the output is going to be okay dangerous for us. This is the major problem in the existing 6G based okay intrusion detection systems. So here you observe a security analyst cannot trust or act or alert they don't understand, and this trust gap is a critical barrier to developing next generation cyber defenses for 6G communication. Because of that, we need to be okay. That means understand how complete AI can create a problem to us. Just you need to be observed here. Feature two, and feature two are there here. है ना? Here, the feature two is good. Network traffic features are highly correlated. But this fluid assumptions leads to evaluating unrealistic out of distribution your data. So that's why the main methods like okay, sharp line have fatal flaw for network security point of view. So this cannot be untrustable okay problem. So in explainable AI, whenever we are supposed to be use okay 6G communication point of view, network traffic point of view, we supposed to be understand okay the feature independence assumptions. The view you supposed to be used to learn that feature, that is going to be defined the actual problem for your data. That's why we need to be understand okay two major concepts, that is the fidelity deficit and semantic deficit or a semantic gap. Here, whatever the features are there, the 6G features are there. That 6G features are going to be produce misleading feature importance because they are based on unrealistic data. So you need to be develop okay some kind of okay that means okay score or okay actionable activities to define your trust or okay something that is going to be narrative to that contextualize attack also. The semantic gap is there, fidelity deficit is there. So this particular two problems we solved with help of okay that explainable a framework. Explainable A framework. So here you observe the model we are training, we are okay, finding okay the NH finder, and we are training the data. So whatever the data is there, we are sending to the model training, NH finder, and training data. Finally, this is like a validation of the data is going to be happen. The validated data is supposed to be fed to this AI models. These AI models finally will use and aggregate okay the information and send to your LLM model. This LLM model is going to be defined 6G attack classes and what kind of intent is there. That kind of information is going to be do this LLM model. So here in this situation, a slow rate attacks are going to be drain servers by sending minimal slow data packets. Minimal. So the faithful attributions are going to be actionable narratives in this particular okay problem actually. That's why this is a new model we are okay developed, and okay, in this new model we are going to be use a pre-trained KNN probabilistic feature model, and we are defining a new score for this particular okay, communication such a way that we developed a explainable feature set. Through that explainable feature set, we are using a global aggregator. So that global aggregator is supposed to be okay help you to okay find okay whether the received traffic is going to be that means okay allowable or not through this particular explainable feature set. Explainable feature set. In the second phase of the training, we are using a find a local neighborhood concept and just in time okay PFM, that means okay probabilistic feature model we are using to train on the fly the data with help of the local neighborhood concepts over here. And finally, we are calculating a conditional value attributions that is going to be based on the local accurate data distribution that brings a high fidelity explanation for our work actually in this. So such a way that you need to be observed a fine-tuned semantic engine we are using with help of the LLM. So that LLM we used here, lightweight LLM Gamma 2B we used, and we generated security descriptions with help of fine-tune this LLM. So the finally we measure trust with help of new explainable trust score. With help of that, we need to be develop this a new metric to quantify fidelity, so that will give a bigger drop performance and better explanation. So these are the results which we used and which we achieved in this particular concept. That means what my intention here to introduce these two discussions. One is the metaverse discussion. One is going to be LLM, AI, and 6G integration discussion. You observe these case studies are going to be introduced to you. That means the how future is going to be there. LLMs are going to be used to monitor to connect to the network, and AI can be used to streamline your that means your traffic or your security aspects point of view, or your efficiency point of view, or your optimization of the network activities point of view. So that's the way this integration is important, especially with respect to our 6G communication. So I want to conclude with help of this particular discussion, and after that I will open for the questionnaires. After that, that means what I need to supposed to be say here. I need to be conclude my discussion 1 minute. Yeah, this is also one. Yes. Yes. So here I want to conclude my discussion here. First of all, you need to be understand 5G and beyond requirements, how 6G is emerging, how 6G can be integrated with AI, ML or LLM or other activities, right? Mainly, you need to be take away from this class. One is you need to be understand 5G use case scenarios. How many use case scenarios are there? 3 use case scenarios are there: EMBB, MMTC, URLCC. And 6G use cases are there. That 6G use cases are based on 5G use cases only. Additionally, they defined 6 more use cases that are immersive communication, integrated and AI communication, hyper reliable and low latency communication, ubiquitous communication, massive communication, integrated sensing and communication. Right? After that, you need to be understand the major discussion for us, that is how 6G security threats are there. Whenever you are talking about a 6G, it's a network. Networks are decentralized distributed. That's why we studied some FL model, that means decentralized learning models. New decentralized and distributed models are there that we discussed, especially we targeted to understand federated learning and split learning concept. Both are very essential to develop new emerging 6G applications. So what is FL, what is the split learning we discussed. In both the split learning and federated learning, we have different type of methods: horizontal federated learning, horizontal split learning, vertical federated learning, vertical split learning, etc. are available. That also we need to be understand. and where we supposed to be use split learning, where we supposed to be use federated learning, why we are not supposed to be use like a traditional federated learning. These concepts always we need to be remember while we need to be do or while we need to be continue our research. As well as whenever you are integrating this AI ML method with your 6G communication or 5G communication, again the specific use case point of view, orchestration point of view, platform point of view, specialization point of view, functions point of view, you're supposed to be use this AI/ML concepts. Then this AI/ML integration will create a new threat vector. Or if suppose you may additionally add LLM, that LLM also going to be create a new threat vector. So that the way you observe, okay, huge research is possible with help of this 5G, 6G, AI, LLM, and integration with okay, whenever you are working, huge okay, security aspects are possible. Clear? And here also we have okay, different problems are there. MEC, mobile edge computing point of view, problems are different. 6G network management point of view, that means okay, 6G orchestration point of view, problems are different. RAN technology, 6G RAN technology point of view are different. And whenever you need to be use 6G concept with ORAN, open RAN communication point of view, that is also different. So, and whenever you introduce this okay, artificial intelligence at the base station level, that means we call it as an intelligent radio. If you are going to introduce artificial at the base station level, that is different. And in 6G itself, reflected intelligent surfaces, RIS is there. RIS point of view, whenever you are using this AML, that creates a new security threats for you. So my conclusion is, if you are going to be carry forward your research or you want to continue okay with the 5G and 5G communication, there are huge okay problem statements are there to solve for you. This is okay what I want to okay discuss with you. Now I am open for my questions. If anybody might have questions, please okay uh, raise your questions. I will try to answer for that. Dear participant, do you have any questions? You can use your chat box and you can place your questions. No problem for that. Yeah, one Paresh Olanki is asking how to apply 6G security because in 6G network is too fast and the latency requirement is too straight, maybe less than 1 millisecond for a slow software checks. Second, whatever the threats are learned in 6G security or might be against theoretical threats, I would like to tell you here 6G threats are different than the normal security threats. Why? Because uh, if a small security attack you may place on 6G communication, the data loss is huge. So you should not okay. You should prepare. I would like to tell you, one packet you lost, you can retransmit the packet, but you lost okay, terabytes of packets. That would be a challenging task. That's why security is so important in 6G communication point of view. Network is too fast because of that. Okay, the new threat vectors are going to be generated. Okay, in 6G communication point of view. That's why I told you, na, you need to be take one example as a network slicing concept is there. In the slicing itself, you have a huge and orchestration of the 6G communication point of view. That are also huge number of okay security problems are there. And the second question you were saying, the threats to learn in 6G security might be against theoretical threats. No. If you want to create, that means okay, that's why I would like to tell you. Right now we don't have a devices, but you're supposed to use sub 7 gigahertz. There is a one band they specified for okay, 6G communication in 3GPP. They said okay, this sub 7 gigahertz band you're supposed to be used for okay your 6G communication point of view. That might be from okay around like a 4 gigahertz to 7 gigahertz in between is there. Use that. You can develop okay new threads and the threats you need to be analyze it. Especially in 6G, 5G point of view, you supposed to be generate the data is going to be CSI data. That means the channel state information data. With help of the channel state information data, you can able to develop many application in a real time basis. Am I reaching you? Yeah, in federated learning, a huge research is going on. Especially, you need to be required a combination of 6G plus federated learning, or what else you require? Yeah, 6G with the 5G communication. Whenever you are talking about simple application, I would like to explain you to understand that actually. There's a beam forming. Intelligent beam forming is supposed to be performed. Whenever intelligent beam forming you perform, here each user required privacy for their communication. Hence, they're supposed to be used federated learning. Whenever they're supposed to be used this way, their CSA data play a crucial role. So data manipulation or model manipulation or member inference attack can be possible to perform in this 6G environment. Right? Any further questions, please? Anyone else might have some questions? Yeah, thank you to all, and thank you Nanda sir and Ravi Madila sir for giving this opportunity. Sir, you are not audible, sir.
Sir, am I audible?
Yes, sir, you are audible now.
Yeah. So I am very much thankful to Professor Batula for sharing his latest research developments in the 5G, 6G communication and use of LLM and other recently developed model in this particular direction. I believe it is very much helpful for the upcoming generation researchers. So thank you for this motivational talk.
Thank you
In
very
this
much, sir.
field.
Thank you very much. So that paper was accepted and presented in TrustCom, sir, which is A-level conference.
All the
The last
participants
case study.
to stay online. Our next speaker, Professor Poonam Singh Madam from NIT Rourkela will join soon. So please be in the link.
Sir, I can leave now? Sir, can I leave right now?
ये क्या कर रहे हो तुम? मुझे बिल्कुल समझ में नहीं आ रहा है.
Sir,
हाँ, हाँ, नमस्ते मैम। मुझे सुनाई नहीं दे रहा है मैम का आवाज।
Hello.
हाँ मैम, नाउ इट इज फाइन।
Oh,
Welcome you, ma'am, to this faculty development program on 5G, 6G wireless communication, 5G and beyond wireless communication. And
thank you.
participant, it is my pleasure to introduce you to Professor Poonam Singh, ma'am, from Department of Electronics and Communication Engineering, National Institute of Technology, Raulkela. Professor Singh obtained her BTech degree from Veera Surendra Sai Technical University, Bulla, and her master degree MTech from NIT Raulkela itself. She completed her PhD from IIT Kharagpur. Uh, she has been a faculty member at NIT Raulkela since 1991. Uh, she had various she held various academic positions at NIT Raulkela, serving as head of the Department of Electronics and Communication Engineering. Her research interests are communication technology using analog and digital communication, wireless communication, spread spectrum modulation, uh, cooperative communication, cognitive radio, multi-carrier modulation, emerging 5G, 6G systems. And she, as a very active researcher, she has various eminent uh, published numerous papers in eminent journals and conference proceedings, and has guided several PhD students at NIT Raulkela. Ma'am, I was an alumni of NIT Raulkela.
Yes, yes, I know. Which
I
year you passed?
I passed at 2009, ma'am.
2009.
7 to 9 I did my MTech actually. You were there at Kharagpur for PhD
Yes,
in that duration. So,
yes.
sure. Over to you, ma'am. Please.
Thank you very much. And so now I will be giving a